This conference will now be recorded.
Okay, so let us talk about today's agenda. One second. All right, so for today, we need to cover the Git branch. We discussed about Git branch yesterday. That is not yet discussed. So today we will discuss that, and then we will talk about some best practices, right? Some best practices in branching. So how a different developer would work together, in the right way and deliver their changes into Git. So we talk about how the company should be creating different branches for their developers. That we will discuss, and after that we will start with a completely new topic, which is not about source code management but about build management. So I will give an introduction about what is build management. If you remember, on the first class, we discussed about the source code need to be converted into some executable file, right? The plain text code written in a text editor is not in a executable form. You need to download the dependencies. Then you may need images, style sheets to make the software look good graphically. And there are many things, right, that need to be done. You will download all the dependency. At the end, you would create one executable file which is ready to run. So build management is all about creating a executable file from the source code. That's what build management is. And then we will take some example project and we will talk about different build management tools, including npm, maven, and pip. Pip is not exactly a build management tool but rather a dependency management tool. But yeah, it can be. This is what we use in python. So like that, there are different examples available, and we will, I will quickly demonstrate different build tools, and then we will go ahead and start building. We will uh, we will go ahead and build everything. So this is the plan for today, and let us start with our pending SCM topics, the Git topics, which are Git branching and best practices in branching. And after we covered them, we will go into the other topics as discussed. So let us start. So the first topic is Git branch, right? So think about this situation, right? You have different developers working on a different functionalities, right? I mean, one developer is working on one issue, the other developer may be working on a feature enhancement, then the third developer could be working on a new feature to be added to the system. So like that, there can be lots of work different developers are doing. And I already told you, when there is a problem that occur, right? I mean, you can always expect problems when your development team do the coding. When they do the coding, you will have to, make sure that the code is tested and it's all looks good, right, before you take this code to your customer. And I might have already told you that this is not a very straightforward process. It includes a lot of teams and a lot of techniques and technologies. So you just cannot do one testing and say that the code is stable. You might miss out a lot of things. So the code need to be tested, tested again, and then it should be marked as, kind of stable but not completely stable or ready for customers. And probably you want to again execute this code to some customer machine, maybe not your top customer, but some customer that you currently work with. And you will tell the customers that this code is not absolutely stable, but it is tested very well and all functions are working, but we have to do some more testing. So will you run this code in your environment, and assume they are running that code in their environment. You might notice more issues, right, coming from the customers, and you will again fix them, and finally you develop the stable code which is ready to go to all your customers rather than one single customer. So there are different stages through which you have to progress, right? So when it comes to Git, the code quality is all about the source code quality, right? Whatever developers are writing is the code, and your software quality depends on whatever your developers write in Git. So within Git itself, you will split them. This is the code that will have potential problems, and this is the next level code that is comparatively stable, and this is the best code that is completely stable. So you can split it, and then your developers are working on different issues. So the developer who are working on a new feature, let them work on one time below, right? Work here at this place, if there is any issue, solve it there itself, then come here and then make it stable and make it completely stable and ready to go to production. So like that, you might want various places within Git, within your Git repository, where you want to store the code, and that is what a branch means.
Hey,
A
Basil,
branch, yeah.
you're not drawing anything, right? Because we're not seeing
Not
anything.
yet, not yet.
Okay,
I'm not
thank
drawing
you.
any.
Okay.
So I will show you how exactly it will work, right? I mean, how exactly uh, you have to plan changing things, right? So think about this. Think about this. I'm calling it a branch in the Git repository, and that is where every developer will be making their commits, right? I mean, that's what developers will do. They keep making the commits, and there is a commit here done by Tom. Now you clearly know what is mean by a commit, right? I mean, I'm not explaining that. So Tom, Jerry, different developer in your team, they keep making the commits, right, inside your code. And you also know that when at some stage you will be releasing this code to your customers, right? I mean, think about, you are developing, Google company is developing the Android operating system. At some point, maybe at this point, they decided that they want to release Jelly Bean, or at some point they decided that this is ice cream sandwich, I mean, right? Then Kit Kat. So different versions of the software can be released after certain issues are fixed. And this is called tagging, that I will talk about. You can actually mark those points, the important points in your development cycle. This is something I'm going to talk about in detail, but right now that is not exactly what I am talking about. I'm talking about, if every developer make their commits in the same place, right? This is going to be very unstable. You expect a lot of issue. Developer would make the issue within the feature they are developing, and when multiple developer work come together, that would result in more problem, the problem with the software integrations, etc. So API can fail, so this kind of problem would come. So there are lots of problems that can occur. So what developer would do is, they will work on a different branch. a branch which is within their laptop, right? Assume this is a branch that is within Tom's laptop, and what Tom decided to do is he decided to work on this particular branch because he know that he is working on a complex problem, the Paytm related problem, which he know takes time. Come on, which he know it will take time, so he don't want to disturb other developer. This is the branch where, let me call it development branch or something. So this is the branch where all developers are. Just 1 second. Okay, yeah, this is the branch where all developers are working on. All right, so assume this is the branch where every developers are working on, and this is the branch only Tom is working on, right? This is Tom's branch. So while Tom is working on something which he know that it will take time, maybe 2 weeks. So for 2 weeks, Tom won't commit anything into the other branch. Tom will keep committing into his own branch, and later when he know that he is done, right? Later when he know that his work is done, he will be merging the code from his branch to the development branch. So at this point, whatever work Tom did will come into the development branch. Until then, the development branch will be free for other developer to fix their problem and commit, right? Any developer who want to fix a small problem, they will keep committing to the development branch. But Tom, since he is working on a major problem, he will keep committing on his own branch and at some later point of time, maybe after 2 weeks, once he verified that everything looks good on his branch, he will then copy everything into the development branch. Now the development branch have all the code from different developers, and other developer would be, either they are directly working on their own branch within their laptop, or maybe they are directly committing to development branch. So it is possible, while Tom is working on his branch, all other developer are working on the development branch, and maybe some other developer is working on his own branch. He will also do the same thing. After he is done with his work, he will merge the code with the development. So at any point of time, you can say development is the branch which will get code from all developers. All right, so this is what I am going to talk about. Tom is going to create his own branch within his laptop, and he's going to start working on his own branch. And then in the development branch, Jerry may be working, or even Tom can also, at the same time Tom want to fix something, he can work on the development branch. That is also possible. Tom can, at the same time, whether there is a fix that he made which is outside Paytm, he will commit into development branch. But if there is a fix that is related to Paytm, he will always work on this particular branch. So generally this is called feature branches. Whenever a new feature need to be added, developer would create a new branch and work in there. So I will show you a demonstration. So the first thing, apparently the Tom would create a branch within his laptop, and then there has to be a same branch with the same name in the remote repository also, of course, right? And then Tom will make some commits in the new branch. Then Tom will push this branch to the remote repository. In the remote repository also, feature branch get created. At the time when Tom push it, initially Tom will be creating the branch only in the local repository. Only when Tom push it, this branch get created in the remote repository. Otherwise, the branch is never created in the remote repository. And at some point of time, Tom would decide that he want to merge his branch with the development branch. Then Tom will perform the merge operation. Either Tom can perform the merge operation, or Tom can ask a senior in your team to do the merge operation. Maybe somebody else want to verify Tom's work before they perform the merge operation. So that is also possible. So we will see how this can be done. Remember, both branches, feature branches and development branch, are available in Tom's local repository. Unless and until Tom push them, it won't be available on the remote repository. So I'm going to create a number of branches, and currently there is one branch we have been working on. The default branch name is master. You might have seen the name master in different places, right? Actually, by default, there is one master. That is not something we created. When you create a new repository, automatically one branch get created. The name is master. Tom has a branch with name master within his laptop, and a remote repository also has a branch with the name master. So what, every time Tom perform the push operation, what exactly happens is, from Tom's master branch, it get pushed into the remote master branch. Commits are getting copied to master branch. That is the default branch in Git. All right. There is a concept of branching in Git, and that is exactly what I'm going to talk about. We have been using the master branch so far, right? In local repository there was master branch, in the remote repository there was master branch, and when Tom execute the command git push origin master, it means that the current code in Tom's local repository, current commits in Tom local repository, which is master branch, will be pushed into the remote repository master branch. That is, it is the remote repository master branch that Tom mentioned along with the push command. It indicates where Tom want to push his commits. All right. In the push command, you mention master. Basically, the developer mentioned that developer is actually mentioning where his current commits need to be copied on the remote repository in the master branch. That's what it means. Okay, just for the clarification. So now let us go ahead and create a branch on Tom's laptop. So just to clarify, we talked about the Git branch, and then what is a branch, right? And now we are going to create a branch. Create and merge branches, right? That's what we are going to talk about. So I go to Tom's computer.
Basil, in a software there will be several number of several number of tasks or several number of features. For every feature, there will be branch. That's what you are telling, right? After completing or updating the code, the each branch will be merged into one main branch. After that, the continuous integration will be going on.
Yeah, we'll come there, Rahul. Yeah, that is where we are going into. Just
Yeah, in the get only, in the get process only, the merging will be.
yeah, merging is different and CA is different. Yeah, you will get clarification today. So what I'm going to do is on Tom's laptop, Tom is going to create a new branch and he is going to work on a new branch. And always remember whatever operations that developers do within their laptop, they make changes on the local repository, right? They don't directly work on the remote repository. When will the remote repository change? Only when there is a push operation. Unless the developer do a push operation, no changes happen in the remote repository, right? Always remember that. Even the branch creation also Tom do in his local repository. Whatever it is, Tom or Jerry, they perform in their local repository, then push to the remote repository. That is how it works. So let me log into Tom's laptop and create a branch. So this is Tom's local repository, working copy. And first of all, I think there are many changes which Tom has to push. So let me make them. Or first of all, I will check if there are any modifications. So no, there are no modifications. This is a patch file that you created yesterday. I don't need that. So otherwise, there are no modifications. So everything is committed, and there are a number of commits which Tom have not pushed yet. Yesterday we didn't run the push command, so I'm just running it. So I'm pushing it to the master, and Tom run this command on his laptop. Then he noticed that currently this is the command that would show all the branches in Tom's local repository. There is one branch with the name master. And if Tom want to create a new branch, the command is git branch, then name of the branch. For example, Paytm. Assume Tom is going to work on the Paytm feature, which is currently not available on the retail store. So he run this command, then what happens is a new branch will get created within the local repository of Tom. Now Tom will run the command git branch. Now there are two branches, master and Paytm, and still master is the default branch. What does that mean? Whatever commits Tom is making right now, all the commits go to the master branch in the local repository. Okay, so star, you can clearly locate the default branch. There would be a star button, which branch you are working on. So now let's say Tom decided that Tom do not want to work on master branch anymore. He want to work on Paytm branch because he's going to start a new job which will take weeks. So it's a bad idea to start with work on the master branch. So he decided to work on the Paytm branch. So that's what he's going to do. First, he will check out the branch that he want to work on. The command is git checkout space Paytm. So do you know what will happen right now? So what content will Paytm have? I just created a new branch. Does the new branch means completely empty? There won't be any content in it. Actually, working copy also is in sync. So you type the ls command, then whatever you see here would be there in the Paytm branch also. So basically what exactly happens is you have a master branch, assume you have a master branch. Assume this is your master branch, right? I'm removing development. I'm writing it as a master branch. I hope it won't confuse you. We will talk about branching practices in detail later on, but no, for now, assume this is the master branch that we are working on. So right now there is nothing called Tom branch or there is nothing called Paytm branch. Assume this is the Paytm branch that you just created. So you already created the Paytm branch, and assume I created the Paytm branch from the master. That's what we did, right? Assume once that I created the Paytm branch from the master branch at this point of time. Just now, this is the time, 8 a.m. today. I'm going to merge my code. I'm going to create a new branch from master to the Paytm. So this is when the new branch got created, the Paytm branch got created, and till then whatever was there in the master, the Paytm branch will also have the same thing. All right, so that is why even at the time of Paytm branch creation, and when you check out the Paytm branch, then whatever was there in your current branch would be there in the Paytm branch also. And whatever change Tom is going to make there, it won't be there in the master branch, and it would come back when Tom make the push operation, right? That's a different thing. Whenever Tom will do a merge operation, sorry, when Tom do a merge operation later on, at that time Tom's work will come back to master branch. Until then it will not. And a master branch can be worked on by other developer. They can keep making their commits, not a problem, right? They can keep making their commits. Other developer, even Tom can also work on master branch, not a problem. And at this point over here, all the code come together in one place. Okay, so let us see that. So Tom have just created a branch and checked out himself to that branch, and currently git status command says no changes, and now Tom is going to make some change in Paytm. So he go to the src folder and he is going to create a new file, paytm.java. Sorry, new feature function, he's writing something, Paytm payment integration with order management software. And then similarly he's doing lots of changes. He's making some small changes himself in the code, and assume he's going to make a commit. He modified this file, so he is adding the file. He created the file, he is adding the file, and he is committing it. New program for Paytm. So where he is committing, where the commit, which branch the commit will go into? Commit will go into the Paytm branch. Why? Because that is his default branch. Currently Paytm is the branch that Tom is working on. Tom ran the git checkout command to switch his branch, and currently it is Paytm. So whatever commits Tom makes will go into Paytm branch, and next time Tom is going to run this command, git push origin master. What will happen? Whatever his current work, currently he is on Paytm branch, there is a new commit in the Paytm branch, it will be pushed to the master branch on the remote repository. No, I don't want it to be pushed to the master branch. I want it to be pushed to the Paytm branch of the remote repository. So till Tom execute this command, the remote repository do not have a Paytm branch. Right now at the time of pushing, right, push is the only operation that will change the remote repository, and Tom run the push command mentioning that Paytm branch is where I want to push my local repository Paytm branch commits. So then automatically a branch get created in the remote repository, and in the remote repository this commit, whatever commit Tom made, would get copied. Okay, so let me work on Jerry's laptop now. Assume now no, Tom made some code change on Paytm branch, and now Tom asked Jerry. Assume they work in the same team, and Jerry is a senior member, and now Tom want Jerry to take a look at the code that he modified. So what Jerry will do is, on his computer, I'm going to log into Jerry's computer. Right, I'm going to log into Jerry's computer. And on Jerry's computer, what first of all he will, he will do a git pull command to get the latest. He got the oh, there is some problem. Okay. All right. So what Jerry did is, first of all, he made a pull operation to make sure that he has the latest. So what is the current state of Jerry's computer? He is working on master branch, and what Jerry can do is he can directly pull the Paytm branch to his laptop. But what will happen, in what git pull command will do, it will pull the Paytm branch, which is on the remote, into the master branch of Jerry. And definitely this is not what Jerry wants. Jerry, at the same time, Jerry wants to verify the code change done by Tom. Jerry do not want to merge his code changes with Jerry's master branch. So what Jerry will do is, Jerry will create a new branch, maybe called Tom's Paytm branch or something like that, Tom's Paytm, because Jerry want to create a temporary branch on his laptop, and then Jerry will check out himself to that. So in the local repository, now there is a new branch that Jerry created, and now Jerry can confidently run the pull command, Paytm. There is a Paytm branch on the remote repository pushed by Tom, right, created by Tom, and that branch in the remote repository, I want to pull it to my local repository, Tom's Paytm branch. So it's done. Now Jerry take a look and go to the SRC folder. Jerry can now see all the code modification of whatever Tom have done. So Jerry, Jerry will verify everything. Did Tom did everything right? And Jerry feels like, assume Jerry is the senior member who is allowed to perform the merge operation. So Jerry take a look of all the code changes which Tom have done, and then Jerry decided that, okay, this looks good. It is time to merge the code to the master. Okay, so assume Jerry is the responsible person who will doing the code merging. So he will run the git branch command. Currently he is working on Tom Paytm. First of all, he will check out himself to master, and currently Jerry is working on master. And now it is time Jerry want to merge the code, whatever is there in Tom's Paytm, with master. Right? I'm talking about this operation. Currently this is Paytm branch on the remote repository and Tom's laptop, right? Tom already pushed this branch to remote repository, and Jerry pulled this branch, and on Jerry's laptop the branch name is something else, it is called Tom's branch. It's anything, Jerry can name it whatever he want to. So that branch contains all the work done by Tom, all the commits made by Tom, and now Jerry decided that the work looks good and let us merge it back to master. Jerry want to perform this merging operation. Whatever commits are there in Tom's uh, branch will come to the master branch, and let us do that. So the command that Jerry will run is, he must be initially on the master branch, and Jerry will run this command, git merge and Tom's Paytm. So this is a local merging that Jerry is doing. Within his local repository, he is performing the merge operation. He is merging Tom's Paytm branch with his branch. Currently it is master. So run this command, and whatever commits are there in Tom's Paytm, they will now come to the master branch. Okay. So Jerry made this merge operation, and at this point of time, all the work has come here to the master branch. Master branch has Jerry's work, or whoever developer made commits to master branch, it's already there. And then now Tom's work got merged over here. So all looks good. And now remember, this happened in Jerry's computer, Jerry's local repository. So unless Jerry do a push operation, he run the command git status, all looks good. This is the patch file. Let me delete this one. Otherwise all looks good. Jerry can simply, after the merge operation, he can simply push the code back to the remote repository. So currently Jerry's master is up to date. Currently Jerry's master branch is up to date, and at this time, this up to date master branch need to be merged with pushed into the remote repository. So assume this is the remote repository somewhere, right? Assume this is the remote repository, the origin. So there you will push to that remote repository master branch. Jerry is performing the push operation. So at this point of time, master branch has everything. So everything will be pushed into remote repository. Right. So this is how it works. So Git allows developers to work on their own branches without disturbing the other person, or without mixing up the work. The work can be split into different branches, and that is the whole concept of Git branching. And in the next session, I will be talking about I will be talking about the best practices. What are the right practices that company follow in branching? This is just for your understanding how the branching can be done, a practical overview. So any questions?
Hi Basil, how the Jerry will know the Tom has created a branch? Like when the
Jerry
Jerry.
won't. Jerry won't. So Tom has to request Jerry to do this. Right? It's more like a, there are many ways to inform Jerry within a company. It can be by informing through some ticket, or through some different system. But yeah.
Basically, when the branch is created from the GitHub server, so when we try to push, is that the same command? Is it git push or git push origin master?
Come again.
So now we are creating the branch in the local machine, right?
Correct.
Suppose we create the branch in the remote server, let's say GitHub server from the UI.
Right.
Okay, then what is the command to push? Is it the same git push origin master or just git push?
So basically, what git push does is, whatever changes are there in your local, your default branch will be pushed into the remote branch. That is the basic push operation will do. So let's assume currently Tom is working on the master branch on his local, and there is a remote branch he is pushing into called Paytm. The exact operation, what happens is, whatever Tom's default branch is on his computer, right now it is master, the commits get copied into the Paytm branch on the remote. So actually in that situation, a merge operation is what happens. So in our case, what we did is we named both local branch and remote branch same. So Tom created a local branch called Paytm, and there is a remote branch called Paytm. Then, during the push command, Tom always mentioned Paytm to be the branch to be pushed. So so there was no merge operation. Does that make sense? If you created a GitHub branch from the UI, right? Assume, and everyone else, just don't worry about the UI part. We will be talking about it. But assume Tom already created a branch in the UI, and when during the push command, he just mentioned that branch. That is the only difference. Otherwise, from the operation perspective, from the workflow perspective, Tom always do the same job.
Okay.
Hi Basil, for all this flow, do you have any flow diagram? Because after the pushing from the Tom again, again we have to pull the code Jerry. Do you have any flow diagram on this?
I don't have, but I can draw one. Yeah, not a problem. Okay, but after a break, take a short break of 5 minutes. We will continue after 5 minutes.
This conference will now be recorded.
Okay, guys, so what we will do is, I'll just quickly show the flow diagram, what I just did, right? So let's, so assume there are two branches, right? I mean, assume this is Tom's laptop. This is Tom's laptop and he has a master branch. All right, so this is the master branch of Tom. And then what Tom did is Tom created a new branch. The new branch name is Paytm. And within his laptop, he did that. Right, and this is the Paytm branch that Tom created within his laptop. Paytm branch, right? And this is the master branch on Tom's laptop. And then what Tom did is, to create this branch, he ran the git branch command to create the branch, and then git checkout command to make this as his default branch. And then Tom made some commit inside the Paytm branch. Whatever commits Tom makes from now, it will go into his local Paytm branch. And after performing the commit operation, what Tom decided to do is he want to make a push operation to the remote repository. So there is a remote repository. The remote repository currently have only master branch. There is no Paytm branch. So when Tom did the push operation to the remote repository, he mentioned the command git push origin Paytm. So what that means is whatever commits that are there locally, it will be pushed into a Paytm branch in the remote repository. Then automatically a new branch get created in the remote repository with the name Paytm, and that is where Tom commits will go. This is the remote repository. And now, what Tom want to do is, Tom want to ask Jerry, right? Tom want to ask Jerry, Jerry want to verify the code change done by Jerry. So in Jerry's laptop, the current situation is this: Jerry has a master branch, and Jerry do not want to pull the Paytm branch directly to master, because then what happens is, right now, if Jerry run the pull command, pull origin master, then origin Paytm, then what happens is the code will come to his default branch, which currently it is master. So what Jerry did is, Jerry decided to create a separate branch. So by running the git branch command, he created a new branch called Tom's Paytm, and then he checked out this branch, and then he ran the pull operation. So git pull origin Paytm, it means the Paytm on the remote need to be copied into his current branch, which is Tom's Paytm. So that is when the commits of Tom has come here, and then Jerry decided that all the changes look good, the code here all looks good, then it is time to merge it. He merged the Paytm branch with master. Remember, the merge operation happens within Jerry's laptop right now, and now Jerry want to push it back to the remote repository, to the master branch, and now the remote repository master branch has the merged code. That means Tom's work as well as other developers' work. This was the workflow. All right. So that's it. And now we will talk about a new topic. What are the best practices in branching? What are the best practices in branching? And that is what we are going to talk about. Okay, great. So as I told you, in companies, the code need to be verified through a complex process, right? Developer make the code change, developer fix the issues, add new features, then make some small feature enhancement, and different people do different job. They will commit themselves into the local repository, maybe the master branch or some branch, or maybe their own branch, and then they will push their code into the remote repository. And then probably, if the code is all looking good, then you want to create a new branch, and that is where you want to keep the stable code. So there has to be a practice that company follow when managing the source code. So I will talk about some best practice, and I wouldn't say this is the practice that every companies are following. No, it's completely depends on their strategies and stuff. But what I'm going to discuss is a proper strategy that you can follow when it comes to branching in Git. And this can be a good interview question also. So please listen, it's very important. So assume, right? Forget about local and remote concept. Okay, I mean, you know that local or remote, it's all same, right? It's all same commits we are talking about. So forget about local and remote. Right now, I'm just explaining what are the best practices in branching, how you should do the branching. So you all know that a developer would keep creating different feature branches within for their own sake. They want to work on a new feature, they will create a separate feature branch and work on that. And after they are done with their job, they will merge their code with the master branch. But generally, master branch is not used for that purpose. You never work directly on master branch. Again, it's not a rule, it is the best practice. Generally, the companies would create a branch called development. Development branch will be created in the Git repository. So every developer can make the commits, I mean, copy their commits into this particular branch, either through a merge operation. Maybe developer is working on a different branch called a Paytm branch. It can be merged with developer. The developer generally get a direct commit permission to the development branch. So if there is a bug fix, that you don't have to create a new branch, you can directly commit into the development branch. So at the end, a development branch is the branch inside a company which would get all the work done by developers. And once the commits have come into the development branch, you want to make sure that the code is tested and verified. And in the first day, remember the first day, what are the different stages in continuous integration, right? You want to take the code, you may want to download all the dependency, you want to compile the code and the dependencies, and then finally you will create an executable file. You want to create a machine and execute this executable file inside the machine, run some manual testing or probably automation testing, and then after doing the automation testing, you want to generate the report, you want to check the report, verify them if they all look good. If there is a problem, you should detect that. So basically, whatever code that developers are modifying, or you can say whatever code is coming to the development branch, need to be verified through a continuous integration process, right? Through a continuous integration process, or maybe manual process, whatever, code must be verified. That is the what I am trying to mention here. And assume at this point of time the code looks perfect, right? No issues are detected when you followed all these things. There was no error in compiling, there was no error in building, there was no error in executable file creation, then server creation went smooth, then running the software in server also went smooth, then you run a different testing, that also went smooth. So everything looks good at this point of time, and now this is time you will decide that the code will be copied into a more stable branch. So this is another branch within your Git repository, but this branch will contain only the stable code, but still you cannot say this is completely stable. You can say it is stable, it is tested for these many things and it is working fine, so probably it is stable, right? Does not mean that you haven't tested it for your customers, you haven't tested it in real time, so these problems are still there. But you can say it is not the worst code, it is a better code you have in here. So in this branch in Git that you create in Git, you will not allow developer to make the direct commit. Direct commits are not allowed in this branch, but developer always make their code change here, then after verifying that it would be merged with staging. So it means that only the stable code come here to the staging branch, and again not completely stable but moderatively stable. And then probably here also you want to run some testing, you want to build, test, right? Then probably you want to run it for a customer server, maybe, right? If you have that chance, do that. And then otherwise, you just replicate a customer environment yourself and then test it there, make sure that everything works fine, follow a complete continuous integration process here also, verify that everything looks good, and then decide that is the code ready to go to production. If everything succeeded, then you would merge it with a different branch called production branch. Every company will have a production branch, and once the code is verified within staging, the next step is to merge the code with production. So production always contains the most stable code that you can figure out. And again, don't assume that it is perfect. No, it may not be. But as far as you know, this is the most stable code And yes, you can feel confident to run this code for your customers. And nobody should ever make any change directly into the production branch. So it is decided by the project managers or the technical architect who verified everything, and then they will show the green flag. Okay, looks good, I think. So just go ahead and deploy it to your customer service. So it is from this place, generally the operation team or DevOps engineer themselves, they will take the code from this place, and this is the code you will run for your customers. For customers, you will have a set of surveys that you created, and in those machines, you would be running this code. Assuming that the code is stable, but still you can expect a lots of bad feedback from the customer. But that is something you should again fix from here itself. If there is a problem right here, if it is found ideal, it is merged with production. If it is not found ideal, then who will fix it? The developers will fix it. They will either fix it in the feature branch, or they will fix it in the development branch. The same process will repeat. These are the fixes that they made, and at the same time there may be other feature enhancement. At this point of time, the code is found to be stable, merged with staging, merged with production if it is found stable in staging also. So this process will repeat for any issues that occur. The same process will repeat. So, and this is going to be a permanent continuous process, and we call it continuous delivery. The code is verified within one place, delivered to the next place. Probably it may not be your customer, but it may be internal team who replicated the customer environment or whatever, and there it is verified. You go to the next step, that is production. So this is a stage by stage process. You run a CI process within every main line, go to the next stage, go to the next stage, and at some point, maybe right now I have drawn only 3 branches, but there may be more. Stage 1, stage 2, etc. Then pre-production, production. So there can be multiple branches. If you want such a high level of testing, the companies created multiple branches and multiple CI/CD process they develop. So this is the way how it works. I'm sorry for this, drawing. I know it doesn't look good, but this is the process of continuous integration and continuous delivery. But don't think or don't worry much about continuous integration and continuous delivery part right now. Right now, the only thing what we discussed is related to Git branching. What are the best practices? So if you do the branching right, that is the start. That is the right start to a proper CI/CD process. This is your strategy of fixing the problems within your company or within the organization. You need this many environments. So you plan it from the Git level itself. Okay, you need a development environment where every developer can put their code together. Then these are the testing to be performed after the code has come into development. Yeah, we are not talking about that right now. I'm just saying, right now you need to think only from the Git angle, but the strategic development would be something like this inside a company. After the code has come to development, these are the different tests that need to be performed. The integration testing need to be performed, because every developer work come into one single place. So there can be conflict, there can be integration problems, all these things can occur. So those testing need to be performed at that time. For that, I need these many machines, and this much time I would need to complete the compilation, building and running that, and then these are the test cases to be executed. These are the reports to be generated, and if there is an error in the report, this is the email ID you should send the email to. So you just make some strategy there itself, and then everything looks good. Then merge it with staging, then run this in a pre-production environment, or maybe in a customer environment, maybe your close customer who is not too big but too friendly. So he allows you to run this code in their environment. Maybe he pay less or something. So there you will run a complete testing and everything. If that is also looking good, then probably the code becomes stable and ready to go to production. So you merge with production. So you can make this kind of strategy, and all this starts from Git. Everything begins from Git. So for your developers, what is their only responsibility? They make change in Git. That is where they will work. Your developers will always work in Git. The remaining process could be up to the operations or to the DevOps. The developer don't need to bother about all of that. They will, if there is an issue, they will fix it, they will commit it, and then there are lots of strategies that starts from there that will continuously test your code, continuously integrate your code, continuously test it, give feedback, continuously deliver it, right? So all the strategy begins from Git. Makes sense, right? So this is the right practice, right? I mean, I wouldn't say right practice. There are companies, different companies follow different practice. This is one of the best practice. So any questions, anyone?
Yeah, Vessel, I have one question. Vessel, we're telling right now there is a continuous means developer deploy the code, then again finally to go to the merge to the master branch, again it to go to the stage like production stage one, stage two like this. But my
Right.
question regarding the patch concept we're telling yesterday, right? If is something in the end customer they found some issue, then to come to the developer, right? Again, it will be process will be continuous the same way or directly it will be in the stage when the code to directly push to the stage. Again, it will be
Yeah, even for patching, all the stages will be completed. You would do a testing, you will run it on development machines, make sure that it's working. You go to staging. Even if it is patching, the patch file will be applied into different environment before it is applied to production. So the strategy would be more or less same.
yeah. But my question is, if somebody found the issue in the production, the end
Yeah,
customer, again the code directly come to the again the developer, again the piece of code they will develop, right?
exactly,
Again, the same code
exactly.
will be directly it will be pushed, or it will be again it will go to again master one, master to stage like this.
Yeah, development to stage to production like this. That's
Okay, then you
exactly.
have to follow again same concept. Okay,
Exactly, exactly.
okay, thank you.
It's always same. I mean, it always has to be same. Maybe some companies do something manual, which which is wrong, which is not good, but they it's necessary. But yeah, it should be like this. Always a developer fix the problem in the feature level or in the development branch, and then it is taken all the way to production.
Okay, Vishnu, thank you.
All right. So yeah, cool. So the next topic is, yeah, build management. So I will give an introduction to what is build management. All right. So yeah, I will start with a question. So what is executable code? So your developer, Tom or Jerry, what they do is they write the source code. It could be in different programming language, maybe Python, maybe Java, or maybe JavaScript, right? And all that. So assume this is the code that they are writing on their computer. Forget about computers, just from now we will talk only from the software perspective. So assume your developers are writing the code here. So they keep writing the code, and I already told you, no developer would write everything at one shot. This code depends on some external dependencies. So assume these are the list of dependencies. Every code will have some dependency that it depends on. So in Java, it's called libraries, and in Python, they are called modules, whatever it is. These are external programs that your program depends on. So if I tell you one scenario, why would the dependency would come into picture? Assume Tom is doing some kind of development. So he is working on the order management. Customer are able to place an order, and after the order is placed, Tom want to make sure that an email is triggered to the developer, to the customers automatically. Every time somebody go to the retail store, buy something, then click on order button and then make the payment. And once the order is completed, an automated email should generate and email would be sent to the customer. So Tom want to develop some email functionality within the code, and then he realized that okay, he don't have to develop it himself. There is already some existing module out there that has all necessary program to send out an email. So rather than Tom developing all the functionality himself for sending out email, he will include that external program, right? Assume this is the external program that Tom want to include. So Tom just include that external program within his code. Then he don't need to, he can save a lot of time. So like that, there would be a lots of external programs that the develop your code would eventually depend on. So what Tom will do is Tom will not, just download all these external programs himself. He will focus on developing the code, and all this external program he will mention in this file, the mail library, email library. This will help you send out an email. And then the PDF library, this will convert the Word file into PDF files. Then this is the something else. For example, the compression library, this will compress the files within your application. So like that, there would be a number of dependency. The PDF library 1.1, it will have a version. Email library 1.3, something like that, right? So all this dependency they will mention in one file. The common practice. And remember, all this dependency will have dependencies. Doesn't sound very good, right? These dependencies can depend on other dependencies, and they can depend on other dependencies. I'm telling the truth. So these are called transitive dependencies. So for your code to work properly, you need all the dependency mentioned in this file to be downloaded, and also their dependency also need to be downloaded. So there may be, probably you have 10,000 lines of code. The dependency will have 10 lakh lines of codes together, and there may be hundreds of dependencies. So you want all the dependencies to be downloaded if you want your software to work properly. So in simple words, what I am saying is, and maybe in Java, a code need to be compiled, right? In some programming language, in most programming language, code need to be compiled into a machine understandable form before it can be executed, right? So that needs to be done. And sometimes the code would contain some graphics, right? If it is a web application like google.com, it would it should have a good looking pattern on the browser. You need HTML, you need the style sheets, you need images, right, like google.com logo. So there would be some graphical elements of the software application that should also be there. You can call them maybe the static images or static files. It could be HTMLs, or if it is web application, they are HTMLs, CSS, and some JavaScripts also. Then some images, photos, or whatever that makes it look good. And so you need the code, you need the dependency, you need the code compiled, you need all the external programs compiled, and once you did everything, you put them all together in one single executable file, which we call the executable code. For example, the dep file in Ubuntu or the exe file in Windows. Your WordPress file is also another example. Remember, when you downloaded WordPress, did you bother about downloading the dependencies, or did you bother about developing the images, style sheets, and good looking styling? Did you do that? No. Actually, the WordPress folder that you downloaded from internet, it had all that. So that is also another example of an executable file. An executable file is something that is ready to run your code. You don't need any complex functionalities, or if in other words, right, think about in a different node, right? Don't think from the same angle. Take a different example. You want to install Firefox. And then you go to the Mozilla website and you downloaded the firefox.exe file. So assume there is no such firefox.exe file. Instead of that, Mozilla says, I can give you the code. Take the code, download all the dependency, then get all the images from this place, and then create your own executable file and then install Firefox. Would you ever use Firefox in that situation? It's too complex, right? You want to get the Firefox source code, and yeah, Firefox will share their code with you. They do that. It's an open source software. You can get the code, but still it's a hell lot of job finding this file, understanding what are the dependencies, downloading each and every dependencies one by one, and getting proper images to make the software look good, and finally combining them all together and create the last executable file. So this is an exe file. So nobody prefer to do all these steps. You prefer to download the exe file, double click and run it. So that is what the importance of the executable code is. You just keep converting your source code into an executable file, and that has to be done very frequently. So anybody who want to run your software, they will always look at the executable file. They don't, I am an operation engineer, I'm not an expert in coding. I would always look for an executable file to run, and rather than taking the source code, compiling it, downloading dependencies, and going through all these complex stages. So this is a very, very important step within a company. Also, when your company develop a software, you should really focus on creation of the executable files. That would make things easy. If you keep creating them, then every time you want to run your software, it becomes so easy. All you need is take this file and run it on a machine, and software got installed, shopping cart got installed just by one click, or prime customer got installed just by one click. So that would make your life more convenient. So this is very important for every company. Even though they have one software, the software consists of 100 software components. Shopping cart could be one component, prime customer could be another component. Like that, there can be different software components which are developed independently. So you want to convert all of them. Maybe shopping cart is written in Java and a prime customer is written in Python, and different software component is written in some different programming language. Your end customers, or I mean within your company, I'm talking about the operation team or the testing team, they don't want to bother about all these things. They just need a executable file that can be executed, and then it all started. So this is very important, that the source code has to be continuously converted into executable code. Your developer keep modifying the source code. They keep adding more code here. They would keep adding more dependencies here. They would keep adding some images, deleting them. So that will happen. So every time some change happens here at the source code level, it should be converted into an executable form. So today's executable file, tomorrow's executable file, last week's executable file. So you should have whatever executable file your developers are working on. That would make things very convenient. All kind of operation would become very convenient if you have the executable file, because you hate, if you are not an expert, even if you are an expert, you hate to work with the source code when it comes to the operation side. You need a direct executable file, and that is what we call build files or artifact. And that is what we are going to learn, how to convert your source code into the executable file form. WordPress is an example. The WordPress files that you downloaded from the WordPress website is a very good example for an executable code. The exe file that you downloaded from Mozilla website is a good example for executable code. The dep file that you install on Ubuntu or Debian based operating system is another good example. There are various forms, right? Different forms, whatever. At the end, this is a code which is ready to run. That is what an executable code means. In case of WordPress, all we had to do is, install Apache and serve them. We didn't bother about the images, HTMLs. We didn't bother about the dependencies. All of them were there already, right? So we will talk in detail tomorrow, and how we can automate this process. Every time developer make a code change, it should automatically create the executable file also, rather than you manually doing all this procedure yourself. We will also do some automation, and that is the key part. It must be automated, and we will talk more about it tomorrow, right? So any questions?
Yeah, Basil, I have a question in Git.
Okay.
Yeah, so in repository, we have the multiple branches, right? Suppose if any one developer delete any branch, for example, if you say that Paytm and this one branch is there, if any developer deleted that branch and he pushed that code into the central repository, do you have any recover mechanism to get back that?
So the only way you can lose a branch is that the branch is available only on Tom's laptop and the remote repository, and Tom deleted the local branch and also the remote branch, then you lost it.
So we cannot get back that branch, right?
No, you cannot get back that branch. That's correct.
Okay.
Oh, was there any problem with my voice? It was good, right? Anyone noticed any voice problem?
Yes, Vessel. Maybe right now it's okay.
Yeah.
10 minutes before I observed. Yeah. Now it's clear.
Okay. Okay, cool. So I hope it's clear, right? And
Basil?
Soumya, send me an email about AWS, or I think I already added you to the portal. You can check there, the AWS program for you. You already have access, I believe. If not, let me know. You can check yourself. Rahul, go ahead.
Basil, actually, we are not having any permissions to delete much development branch because I'm thinking like that. Why? Because we are invited like a collaborator in the company, right? So we can't delete that master branch or that main branches like that.
Permission can be restricted. Yes.
Yeah.
Yes.
One more doubt, Basil. Basil, you will explain about how we can able to see the whatever the command is done by some particular person, like the particular UI, particular ID, like that you had told, right? We can see that by using some particular ID or some particular name or some particular email address.
Git log command will show you all the commits. Is that what you're asking?
Yeah.
Yeah.
Whatever
Git
the
log.
commit, what are the changes has been done.
Yeah. Git log. Okay, cool. So thanks everyone. We will continue tomorrow. We will start with the build management practicals from tomorrow. See you tomorrow. Bye.
Thank you,
Thank
Basil.
you.